So we are continuing chapter 7, that is alternating current. For fast recap. In the case of resistor, there is a no phase difference between EMF and current. It means current and voltage are same phase. In the case of inductor, with respect to current, voltage is leading by 90 degree. In the case of capacitor, with respect to current, voltage is lagging by 90 degree. So we are going to combine all three together. So that is called LCR in series. So LCR. What is L? L means inductor, C means capacitor, R is a resistor. LCR in series. So it is a resistor, it is an inductor, it is a capacitor. So voltage across resistor is VR, voltage across inductor is VL, voltage across capacitor is VC. Combine everything and connect it to AC source. It is a AC source. It is a resistor, it is an inductor, it is a capacitor. So what is it now? In the case of resistor, with respect to current axis, voltage across resistor, same direction. In the case of inductor, with respect to current axis, voltage is leading by 90 degree. In the case of capacitor, with respect to current axis, voltage is lagging by 90 degree. So till this you can ask me in a doubt. Normally we memorize the word civil. C-I-V-I-L. In the case of C na capacitor. So capacitor I come first, V come next. So capacitor, in the case of capacitor, current leads voltage. That is voltage is lagging. VIL. In the case of inductor, voltage leading the current. So inductor voltage lead agum, capacitor voltage lag agum with respect to current. Any doubt? So we are combining all the three phases individually together. So with respect to current axis, voltage across resistor, no phase difference. Inductor voltage is leading with respect to current, 90 degree. Capacitor voltage is lagging with respect to current, 90 degree. Here you can see, I drew VL is bigger line, VC is smaller line. It means I assumed VL value more than VC value assumed. Therefore, VL is bigger line, VC is small line. So, wound pointer, VL pulling upward direction, VC pulling outward direction. So, what is net effect? Net effect is this direction, VL minus VC. So, wound pointer, VL மேல இருக்குது. Example 7 volt. VC கீழ இருக்குது. Assume 3 volt. Then what is net effect? Both are acting opposite direction. Net effect is what? 7 minus 3. That is 4 volt. So, on the logic body, VL is acting upward direction. VC acting downward direction. So, net effect is VL minus VC. If VL minus VC acting this direction, VR is acting this direction. The net effect is along this direction. From the last year's parallelogram law vectors, VL minus VC acting this direction. VR is acting this direction. So, resultant is V along this direction. To complete the parallelogram, so I can take this point as a main particular. It is A, it is B, it is C. So this angle is phi. This angle is phi. So from triangle ABC, I am going to apply Pythagoras theorem. So AC square is equal to what? AB square plus BC square. What is AC square? That is V square. AC is V. What is VB square? That is VR square. AB is VR. What is BC square? This distance. What is this? Nothing but VL minus VC. So VL minus VC the whole square. So V square is equal to, instead of VR, I into R. Instead of VL, I into XL. Instead of VC, I into XC. Whole square. Because last class in the case of resistor, V by V equal to IR. In the case of inductor, V is equal to I into XL. In the case of capacitor, V equal to I into XC. If resistor, inductor, capacitor எல்லாமே இருந்ததுன்னா V is equal to IZ. It is just a Ohm's law தான். Resistor மட்டும் பார்த்தீங்கன்னா V equal to IR. Inductor மட்டும் பார்த்தீங்கன்னா V equal to IXL. Capacitor மட்டும் பார்த்தீங்கன்னா V equal to IXC. Collective பார்த்தீங்கன்னா V equal to IZ. Square வரும் this side. So V square is equal to, I square R square. Plus you can take I square outside. It is XL minus XC the whole square. So V square is equal to I square into R square plus XL minus XC the whole square. Now we are going to take square root both sides. So square root both sides. V square is V. I square is I into root of R square plus XL minus XC the whole square. Bring I this side. V by I is equal to square root of R square plus XL minus XC the whole square. இங்க V by I என்றது collective resistance. So V by I is equal to R in the case of resistor. V by I is equal to XL in the case of inductor. V by I is equal to XC in the case of capacitor. V by I is equal to Z in the case of resistor, inductor, and capacitor. So V by I equal to Z. Z is equal to square root of R square plus XL minus XC the whole square. So the Z is called what? Impedance. Impedance அப்படின்னா it is a collective resistance. It's a collective resistance. Any doubt you can ask me now. Now we take the same diagram, same phasor diagram. With respect to current axis, voltage across resistor, no phase difference. Based on the first page. With respect to current, VR, no phase difference. VL is leading, VC is lagging. அதை accept பண்ணி VL is leading and VC is lagging. And I assumed VL value is more than VC value. That's why VL is bigger line, VC is small line. And at point A, VL is acting upward direction, VC acting down direction. The net effect is along this direction, that is VL minus VC. And VL minus VC acting this direction, VR acting this direction, resultant of this acting this direction. It is V, this angle is phi. This phi is called phase angle. This phi is called phase angle. So I am going to find the value of phase angle. So the question is, what is phase angle? To find the phase angle, I am going to take a triangle ABC. The triangle ABC, I am going to find tan phi. What is tan phi? It is opposite by adjacent side. So tan phi is equal to opposite is BC, adjacent is AB. So tan phi is equal to what is opposite? It is VL minus VC in VR. And we know very well what is VL as per Ohm's law? I into XL. What is VC as per Ohm's law? I into XC. What is VR? I into R. So tan phi is equal to, take I outside, XL minus XC by I into R. Here we are going to cancel I and I. So we are getting tan phi is equal to what? XL minus XC by R. And from this you can find y also. Y is equal to tan inverse of XL minus XC by R. So this formula is called what? Phase angle. In the diagram, this is voltage diagram. The given diagram voltage diagram, we can draw resistance diagram. Instead of VR, I put only R. I எடுத்துடலாம். Instead of VC, I can write only FC. Instead of VL, I can write only XL. And what is difference? XL minus XC. Complete the right angle triangle. It is phi, it is Z. And it is XL minus X. So same diagram, V க்கு பதிலா V na voltage, 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 voltage. Voltage போடுறதுக்கு பதிலா if you use resistances, instead of V, IZ, take only Z. Instead of IR, only R, take only R. Instead of VC, IXC, take only XC. Instead of VL, IXL, take only XL. It is called impedance phasor diagram. So phi is called what? Phase angle. From same diagram, with respect to current, VR is same direction, no phase difference. VL is leading, VC is lagging. I am assuming VL value is more than VC value. Therefore, net effect is VL minus VC. So it is a resultant, it is V. So complete the parallelogram. This angle is phi. Now we are going to find what is cos phi from the triangle ABC. It is A, it is B, it is C. From triangle ABC, what is cos phi? What is cos phi formula? Adjacent side by hypotenuse. So cos phi is equal to adjacent side is AB, hypotenuse AC. So cos phi is equal to VR by V. Cos phi is equal to, as per Ohm's law, what is VR? I into R. What is V? I into Z. Here I cancel ஆயிடுமா? What is cos phi? So cos phi is equal to R by Z. இது ஒரு formula. இல்ல Z நான் full value போட போறேன் அப்படின்னா you can take the Z value from here. So from this formula, what is Z? Z is nothing but square root of R square plus XL minus XC whole square. I'm going to use this here. So cos phi is equal to R by root of R square plus XL minus XC the whole square. So you either use the first formula or you can use second formula, depends on the question. If they ask derivation, write both. And this cos phi is called power factor. So question paper cos phi கேட்க மாட்டாங்க. They ask you what is power factor. So power factor தான் cos phi. Power factor தான் cos phi. Phase angle tan phi. If they ask phase angle, use tan phi. So question paper power factor கேட்டிருக்கா, phase angle கேட்டிருக்கான்றது careful படிச்சுட்டு then you start solving. Any doubt? Resonance in LCR circuit. So ஒரு ரெசிஸ்டர், இண்டக்டர், கெப்பாசிட்டர் 3 சீரிஸ் இருக்கு. இதான் ரெசிஸ்டர், இதான் இண்டக்டர், இதான் கெப்பாசிட்டர். All three attached to AC source. Then what is the condition for resonance? நீங்க 11th படிச்சிருப்பீங்க. What is resonance? Resonance called frequency match. Okay, frequency match ஆச்சுன்னா that is called resonance. So we know that in the case of LCR, what is current? Actually, current I is equal to V by R in the case of resistor. Current I is equal to V by XL in the case of inductor. Current I is equal to V by XC in the case of capacitor. Current I is equal to V by Z in the case of resistor, capacitor, and inductor. So இங்க resistor இருக்கு, inductor இருக்கு, capacitor இருக்கு. Then what is I? I is equal to V by Z. Equation 1. We know that from the previous pages. கண்டுபிடிச்சோம். Z கண்டுபிடிச்சோம். Z is root of R square plus XL minus XC the whole square. This is the value. Equation number 2. So, very important, resonance condition like current maximum. Current maximum இருக்கணும்னா Z should be minimum. Okay. To get Z is equal to minimum, condition is XL is equal to XC இருக்கும். So, I write the condition. At resonance, value of current is maximum. So, corresponding impedance, that is called Z, is minimum. Z is minimum. Z, that is called impedance. Impedance, collective resistance, is minimum only if XL value is equal to XC value. So the value of XL is equal to value of XC இருந்தா மட்டும் Z minimum. இப்போ போட்டு பாருங்க, XL equal to XC equal to X னு வச்சுக்கலாம் for reference. Z is equal to what? Square root of R square plus X minus X the whole square. Z is equal to square root of R square plus 0. Z equal to root of R square. Z is equal to R. So very important point. Impedance is equal to resistance. Impedance value exactly equal to resistance value. Yep, only at resonance. At resonance, current is maximum. To get the maximum current, is it கம்மியா இருக்கணும்? Z is minimum. Is it எப்ப கம்மியா இருக்கும்? Only if XL equal to XC. If XL is equal to XC, Z is equal to R, then Z is minimum, current is maximum. Doubt in this part? So, at resonance, what is the condition? XL is equal to XC. So, condition for resonance. Therefore, condition for resonance. XL value equal to XC value. What is XL formula? Omega L. Last class படிச்சோம். What is XC formula? 1 by omega C. Last class படிச்சோம். ஒரு graph போடுறேன். It is a omega versus current graph. From the graph, it is very clear. Initially, omega increases, current also increases. At one point, current is maximum. That frequency is called omega naught. After that, current decreases. In a graph. This graph is called what? Resonance graph. It is a resonance in LCR. It is very clear, only at one particular frequency, only current is maximum. But current always maximum கிடையாது. So current I become I naught, only frequency omega naught. அந்த இடத்துல மட்டும்தான் XL value equal to XC value இருக்கும். Not always. அப்ப XL equal to XC இருக்குன்னா, frequency should be omega naught. Clear? Now cross multiply, we get omega naught square is equal to 1 by LC. And take square root, omega naught is equal to 1 by root LC. So it is the last answer. But we can continue. Omega naught is equal to 2 pi nu. What formula இருக்கு? That is equal to 2 pi nu naught. Therefore, 2 pi nu naught is equal to 1 by root LC. And nu naught is equal to 1 by 2 by root LC. So both formulas are right. So you can, in exam, if they ask you find resonant frequency, you can find both omega naught as well as nu naught. And only at omega naught XL equal to X. Only at that point current is maximum. Clear?